Good evening, ladies and gentlemen. Let's take a look at how to finish up our plastic money activity. Now, if you are just starting day 2, the first problem says once your payment falls under $20, you pay off the remaining balance. Now, I am amending that to state once your balance after interest falls under $20, you pay off the remaining balance. Now, how many months will it take for you to pay off the $500 debt? Well, let's take a look at our spreadsheet. Now, I took the liberty of creating a spreadsheet that had a $500 beginning balance, a 30% APR. That's where I'm getting this 2.5% from. I divided this by 12. So each of these numbers is my beginning balance times about 0.025. Yours may be a little bit different because you had a different APR than me. But I did decide to go ahead and calculate my minimum payment as the 5% of my balance after interest. So that means that each time I was taking whatever was in this column times 0.05. So notice that my numbers are changing as I'm going through. Now, to figure out your total interest, you have to take this all the way to the end. Now notice that mine is extending pretty darn far. It took 3 entire pages for me to reach a point where my balance after interest was under $20, so I could pay off my debt and get 0 over here for my balance after payment. And at the bottom here, this column was my interest payments. If you add all of these up, so basically the formula that you want to write for this is the sum of our very first interest charge, which in this case is going to be, I think it was cell C3. This was the third cell in column 3 because this is cell 1, cell 2, so cell 3. So the sum of cell C3 all the way through, that's what the colon means. Let's see, each of these cell numbers was 2 more than my payment number, so this would be C125 for me. Now, you may have a different ending value here depending on when your interest actually ended. But that's how I figured this part out. All right, please go back and watch my video on how to use sheets in order to calculate credit card debt, and you'll see exactly how to do a lot of these formulas. Now, this amount right here, this is how much interest I had to pay. So, based on that, I had to pay $458.13 in interest. That's above and beyond the $500 that I originally charged. All right, so I had to pay a total of $958.13 when all I wanted in the first place was something that cost me $500. I had to almost pay double the cost of the item in order to charge this way. All right, now, when you consider the reason that we were choosing these credit cards, an eMusic gift card, a candy bar, a free pizza, is a free pizza worth this? That's up to you to decide. So you're going to explain why or why not that original thing that we were looking at on our credit card come-ons. All right, so the snookered bar, the pizza, a free movie ticket, or a $10 eMusic gift card, is it worth paying this much extra? All right, that's for you to decide. Now, number 4 says using the payment number as your X variable and the balance after payment as your Y variable, represent your debt using a graph. Now, I'm going to show you guys how to kind of turn this entire spreadsheet into a table that you can use to then be able to represent using a graph. So the first thing that I did is I wrote down what X equaled and what Y equaled. So X was my payment number and then Y was my balance after payment. All right, so I have those two columns in gray here on my printout of my spreadsheet. Now the first few payments that I wrote down were just, payment 0 was just my payment number 0, my balance after payment was $500 because in month 0, you don't really pay anything. All right, that's before the interest starts being charged, before you start having to make payments. But then the next month, all right, so payment number 1, my balance after payment was $486.88. I got that from right here. And then payment number 2, it was $474.09. Payment number 3, my balance after payment was $461.65. Now, if I were to go through and try to turn all of this into a table, this would take forever to graph. And I don't know about you guys, I don't have that kind of time. So what I decided to do instead was just go every 10th number. So I'm going to start writing down the 10th payment number, and then the balance after payment, and then the 20th and balance after payment, and so on. And that's how I got this table. Now this is actually the table of points that I'm going to graph. And I apologize if you hear meowing in the background. That would be my cat lecturing me for still working. She's rather irritated with me right now. That's also why you see a different wooden background as I'm filming this, because she is unwilling to let me work unless she can cuddle in next to me. So, payment 0, I still owed $500. I went through and I created a set of axes here. My balance after payment is my y-axis, my number of payments is my x-axis. And I just went ahead and made even spaced tick marks here to represent my 10th payment, my 20th, 30th, 40th, and so on. I'm going by tens on this. I need to extend this just a little bit. So I can get all the way to that 120th payment. And then going up, I basically, each box is worth about $20. So this would be 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. You want to do your scale based on what's going to be easiest, depending on the graph that you're working with. Now the graph grid that I found for you might actually work with the scale, but I'm not entirely sure. I'm using my own graph paper for this one. Now as I go through and I start filling in these points, payment 0 was 500, and then I'm going to skip to payment 10. Now the reason I have these first 3 is to help us write our equation towards the end of this paper. So payment 10, I still owed $383.22. So payment 10, 300, 20, 40, 60, 80, 83 something would be just a little bit above that. And you just kind of estimate about where that point is. It doesn't have to be perfect. Payment 20, I still owed $293 and something cents. So I'm going to go up to 200, 20, 30, or 20, 40, 60, 80, 90 would be halfway, a little bit higher, would be a little bit more than halfway to that 300 now. Payment 30, I still owed $225.11. So this would be 220. Now 30 would be halfway, so 25 would be about a quarter of the way up there. And then 40, 172 something. So this would be 100, 20, 40, 60, 70, and it was 72, so just a little bit above halfway. And you can see that this is actually starting to take a bit of a curve. Payment 50 was about 132 something, so this would be 100, 20, and then 30 would be about halfway up there. And then payment 60, I still owed $101.35, so just a little bit above the 100. And now you can really see that curve starting to form. Payment, let's see, 70 is about $77 and something cents. So payment 70, 20, 40, 60, 70, and then a little bit more than halfway up again. 80, 59.53, so right below 60, 20, 40, 60, just a little bit below. 90 is at 45.63, so 20, 40, 50 would be halfway, so halfway below that. 100, 34.97, so 20, 30, 35 would be a little bit above there, and it's definitely tapering off now. 110 is at 26.80, so 20, and then 26.80 is right about there, and then just above the 20. So if we start connecting these dots, it's going to start making kind of a smooth curve here, and it's going to kind of keep on going. So this definitely does not look linear, and the reason it's not linear is that 5% payment that we were making. As your payment is decreasing by 5% and the interest that you owe is staying as a percent, anytime you're dealing with percent increase or decrease, you're dealing with an exponential function. In this case, we have a combination of both percent increase and percent decrease, which is why we're going to have to come up with our own equation. All right, so this is what my graph ultimately turned out like. All right, now back to our directions. So describing the graph, I definitely described it as exponential, not linear. And again, it's because I'm dealing with percent increase and percent decrease. That is always an exponential relationship. And then write an exponential function for the credit card. So the easiest way to write an exponential function is to consider the formula that we use for exponential functions. We have y equals our initial value times our multiplier to the x power. So our initial value that we charged was 500. We already know that. So I'm going to go ahead and enter that in. And then I have this mystery multiplier that I need to find. Well, I want you to consider, if you are multiplying to find the next number, so if you multiply to go from 500 to 486.88, and if you multiply to go from 486.88 down to 474.09, what should we do to go backwards? In other words, if we're multiplying by b to get this number, and then we're multiplying by b again to get this number, you're essentially solving the equation. 500 times b equals 486.88. Divide both sides by 500. And that's why your math teachers will often tell you to divide backwards up the table. You're reversing the multiplication that you had originally done to get the answer in the first place. And you're going in reverse order in order to find that, because that's what will solve this equation. Now, if I work that out and I take 486, I'm not sure if that's going to show up because this is very brightly backlit. 486.88 divided by 500, that equals 0.97376. Now let's try this next one. Now I'm not going to write the equation again, I'm just going to write the division problem. I need to take my number that's lower down in the table and divide it by the one that's right above it to undo the multiplication that got me there in the first place. And if I do that division, 474.09 divided by 486.88, that gets me something that's really, really close to this. 0.97373, so it's really, really close. I'd say let's approximate this at about 0.974, and we have something that's really close to the graph that we had just made. This does not have to be perfect, it just has to be approximate. All right, so this is my exponential function. Now yours is going to look different because your numbers are different, but it should be something kind of similar to this. So over here, I would write in y equals 500 times 0.974 to the x power. Right? And that completes day 2. Now when you get to day 3, you're looking at a what if scenario. We all like to ask what if. What if you owe $25,000 on a credit card that charges a 40% APR and a minimum payment of, now this should say 3%. I don't know why it turned into a dollar sign there. It should be 3%. So please do make sure that that actually says percent. All right, so you're creating a Google Sheet to calculate how long it will take for you to pay off this debt. So remember, this right here is 3%. And what I want you to look at is, what is the trend? Is your balance after payment increasing or decreasing in this scenario? Will you be able to pay it off? And then if you were to change what you pay to more than the 3%, significantly more than the 3%, let's say 5%, 7%, something like that, then what's happening? So you're playing around with the what if scenario and just kind of answering these questions, and then your conclusion is basically just telling me, what did you learn about credit card debt and payment habits that you can apply to your future adult financial habits? So this is more of a self-reflection than a right or wrong answer. All right. And I hope this helps you guys to be able to complete your project. Have a good night.